Welcome back. We have a question in front of us that reads, a block of mass 8 kilograms causes a spiral spring to extend by 0.32 meters from its unstretched position. The block is removed and another body of mass 0.4 kilograms is hung from the same spring. If the spring is stretched and released, what is the angular frequency of the subsequent motion? Take G is equal to 10 meters per second square. Solution. There are important things that we have to understand regarding this problem. We have a spring mass system that is going to involve oscillation. So we need to apply the knowledge that we have from elasticity and from simple harmonic motion. Now let's try to interpret the question. Initially, the mass that is attached to the spring is 8 kilograms, and this causes an extension of 0.32 meters. After that, the 8 kilogram mass is replaced with a 0.4 kilogram mass. That is the second case, right? Obviously, that will also cause a certain extension. The question is asking us to find the angular frequency. Okay? Remember, angular frequency is represented with the symbol omega. It can also be called angular speed or angular velocity. All right? You should never confuse angular frequency with the word frequency alone. Okay? In fact, they are related with the formula. The angular frequency is equal to 2 pi f. This is the angular frequency, and this is the frequency. I hope that point is clear. So moving on, in the first case, an 8 kilogram mass causes the spring to extend by 0.32 meters. So the extension, we can call that E or X if we want, especially if we are dealing with simple harmonic motion. So that is 0.32 meters. Now, if the system is suspended vertically, then the force that is going to cause the spring to extend is going to be the weight of the block itself. So it means the force will be 80 newtons, since force is equal to mass times gravity. Okay? The first information can give us the spring constant, which is also called the force constant if you like. So first, F is equal to mass times gravity. The mass is 8 kilograms multiplied by gravity is 10. That is 80 newtons. Now, using F is equal to Kx, where x is the extension. If I want to find K, I will divide both sides by x. So therefore, K is equal to F all over X. So using the information of the first case, we can be able to obtain the force constant, okay, or the spring constant. So the force is 80 newtons divided by The extension there was 0.32 meters. So the force constant is 250 newtons per meter. If that is known, then we can move on to the second case where the 0.4 kilogram mass is now attached to the spring. And we want to know the angular frequency in this case. Okay? So it says if the spring is stretched and released, what is the angular frequency of the subsequent motion? That is when you attach the 0.4 kilograms mass to the spring. The formula for angular frequency, omega, is equal to the square root of the spring constant or force constant, if you like, divided by the mass. Okay? This is the formula that you should always remember when you are dealing with spring mass system. Using angular frequency is equal to the square root of K divided by M. What is the spring constant that we have calculated? It is 250 newtons per meter divided by the mass that is attached to the spring is 0.4 kilograms. So that will be the square root of 250 divided by 0.4 is 625. So what is the angular frequency? The angular frequency is the square root of 625 is 25. So that will be radians per second. All right. We have another question here. A block of mass 7.6 kilograms causes a spiral spring to extend by 0.38 meters from its unstretched position. The block is removed and another body of mass 5 kilograms is hung from the same spring. If the spring is stretched and released, what is the angular frequency of the subsequent motion? So this is similar to the first question that we have answered. The first case, the 7.6 kilogram mass is attached to the spring and it extended by 0.38 meters. Then the 7.6 kilogram mass is removed and the 5 kilogram mass is attached, setting the spring mass system into oscillation. So they want us to find the angular frequency during that oscillation. That is when the 5.0 kilogram mass is hung from the spring. Solution. The first mass that we have is 7.6 kilograms. So we know that the force that is going to be associated with that mass is mg. So that's going to be 7.6 times 10, which is 76 newtons. The extension x is 0.38 meters. Now, using Hooke's law, F is equal to Kx. To find the spring constant or the force constant, we divide both sides by x. K is equal to F divided by x. The force is 76 newtons divided by the extension is 0.38 meters. So that will be 200 newtons per meter as the spring constant. So using that information, we will now answer the question which asks us to find the angular frequency when the 5 kilogram mass is attached. Okay? So we know that the angular frequency is equal to the square root of the spring constant divided by the mass. So the angular frequency will be the square root of 200 divided by the mass is 5. The angular frequency will be the square root of 200 divided by 5 is 40. So what is the square root of 40? We can express our answer in short if we want. So root of 40 can be the same as the square root of 4 times 10. The square root of 4 is 2, so that will be 2 root 10 radians per second. Or if we like, we can just give the answer as 6.32 radians per second. All right. A block of mass 2.56 kilograms causes a spiral spring of original length 0.80 meters to extend to a length of 1.12 meters from its unstretched position. The block is removed and another body of mass 9.8 kilograms is hung from the same spring. If the spring is stretched and released, what is the period of oscillation during the subsequent motion? Take acceleration due to gravity as 10 meters per second square. So let's try to break down this information that we have here. Solution. We have a spring mass system here. Let's say this is the spring. The original length L0 of the spring is given as 0.80 meters. But when the mass of 2.56 kilograms is attached to the same spring, the spring has a new length of 1.12 meters. So what can we derive from this information? This level here, when the mass was not attached, the spring has an unstretched length of 0.80 meters. So that is the original length. But after the spring has a mass of 2.56 attached to it, the spring assumes a new length of 1.12 meters. So this tells you that there was a change in length, and that change in length is what we call extension. So what will be the extension there? The extension x is equal to the new length minus the original length. The new length is 1.12, so minus the original length is 0.80 meters. 1.12 minus 0.80 is 0.32 meters. So one thing that is clear here is that the force that is going to cause the extension is provided by the mass of the block that is attached. We're going to have a force F that is due to the weight of the object. But what is the magnitude of that force? Force is equal to the mass times gravity. The mass attached is 2.56 multiplied by the acceleration due to gravity is 10. So we're going to have 25.6 newtons. We know that F is equal to Kx, that is the applied force is equal to the spring constant multiplied by the extension. If we want to find the spring constant, we divide both sides by x. So therefore, K is equal to F divided by x. The applied force is 25.6 newtons divided by the extension is 0.32 meters. So which means the spring constant is 80 newtons per meter. So let's go and answer the question now. It wants us to find the period of oscillation when the 9.8 kilograms mass is hung from the same spring. So the mass given is 9.8 kilograms, and we know that the spring constant is 80 newtons per meter. So with this information, how do we find the period? The period is equal to 2 pi, the square root of the mass divided by the spring constant. So that is the formula that you should remember. The period is equal to 2 pi, the square root of m divided by k. So you should be careful to know where k is a numerator and where m is a numerator for the different formulae of the spring mass system. Using T is equal to 2 pi square root of m divided by k, that will be 2 pi, the square root of the mass is 9.8 kilograms divided by the spring constant is 80. So that's going to be 2 pi, the square root of 9.8 divided by 80 is 0.1225. So that will be 2 pi multiplied by what is the square root of 0.1225 is 0.35. So 2 times 0.35 is 0.7 pi, okay, as the period in seconds. But if we want to substitute the value of pi as 22/7, so we're going to multiply that by 22/7, which means we will have the period as 2.2 seconds, okay? So that is the period. It is 2.2 seconds. A block of mass 4.84 kilograms causes a spiral spring to extend by 0.05 meters from its unstretched position. The block is removed and another body of mass 12.5 kilograms is hung from the same spring. If the spring is stretched and released, what is the frequency of the subsequent motion? We're going to take acceleration due to gravity as 10 meters per second square and pi as 22/7. So here we have to be careful. We are asked to find the frequency, not the angular frequency. Remember, the frequency is different from the angular frequency, okay? Solution. The mass is 4.84 kilograms. That causes an extension of 0.05 meters. So with this first information, we can find the applied force, which is going to be mg. That is going to be 4.84 times 10. So that is 48.4 newtons. Now, using Hooke's law, we know that K is equal to F divided by X. So the force is 48.4 newtons divided by the extension is 0.05 meters. When you do the math, we have 968 newtons per meter. That is the spring constant, okay? It never changes. So we are asked to find the frequency when 12.5 kilogram mass is hung from the same spring. So which means now we are dealing with a mass of 12.5 kilograms. but the spring constant K is 968 newtons per meter. What is the formula for frequency? Well, you have two formulae that you can use. Okay, frequency is equal to 1 all over 2 pi the square root of K divided by M. All right, so that is one of the formula that is associated with the frequency. So if that is the case, let's try to substitute. We're going to have F is equal to 1 all over 2 pi. The square root of K is 968 divided by the mass is 12.5 kilograms. So that's going to be 1 all over 2 pi times the square root of 968 divided by 12.5 is 77.44. So F is equal to 1 all over 2 pi times what is the square root of 77.44 is 8.8. So which means the frequency is equal to 8.8 divided by 2 pi. So frequency will be equal to 4.4 divided by pi. Now that is going to be in hertz. But if I want to substitute the value of pi, frequency will be equal to 4.4 divided by 22 over 7. So that is F is equal to 4.4 divided by 22 over 7. So we can express this as F is equal to 4.4 times 7 over 22. So frequency will be equal to 4.4 times 7 is 30.8 divided by 22. So therefore frequency is equal to 1.4 hertz. Okay, that is the frequency. But if you can remember the formula for period, which is period is equal to 2 pi the square root of M divided by K, and you know that period is also the inverse of the frequency. So we can say 1 over F is equal to 2 pi the square root of M all over K. So now squaring both sides, that is going to be 1 over F all squared is equal to 2 pi the square root of M all over K all squared. So that will be 1 over F square is equal to 2 square is 4, then pi square is going to be pi square, root of M square will just be M, divided by root of K square will just be K. So if we cross multiply, we will have 4 pi square M F square is equal to K. So to make F square the subject of the formula, I will divide both sides by 4 pi square M. 4 pi square M. And therefore this will cancel out. So it means F square is equal to K divided by 4 pi square M. So in other words, if at all I want to find the frequency, that will be the square root of K all over 4 pi square M. So this is also another formula to find frequency. Okay. Now if we want to use this, that will be F is equal to the square root of what is the spring constant. That is 968, right? 968 divided by 4 times pi is 22/7. That will be squared times the mass is 12.5. So the frequency will be the square root of 968 all over 4 times 22 square is 484 divided by 7 square is 49. So multiply that by 12.5. We'll have frequency is equal to the square root of 968 all over 4 times 484 over 49 times 12.5. If we should leave that in fraction, that will be 24200 over 49. So the frequency would have been the square root of 968 times 49 all over 24200. So the frequency will be the square root of 968 times 49 is 47,432. So that will be over 24,200. So the frequency is equal to the square root of 47,432 divided by 24,200 is 1.96. So what is the square root of 1.96? We'll have 1.4 hertz. So you see, whichever formula is simple for you, you can use that. So lastly, I want to prove to you how we have that formula F is equal to 1 all over 2 pi the square root of K all over M. Well, if you can remember these two formulae, that the angular frequency is equal to the square root of K all over M, and the angular frequency is also equal to 2 pi F. So if we equate these two equations, we can say 2 pi F is equal to the square root of K all over M. To make F the subject of the formula, we divide both sides by 2 pi. Okay, so this will cancel this. So therefore, F is equal to the square root of K all over M all over 2 pi. Now, this is also the same as the square root of K all over M divided by 2 pi, right? So you can say F is equal to the square root of K over M times 1 all over 2 pi. So that will be the same as F is equal to, if we bring 1 over 2 pi in front, we'll have 1 over 2 pi the square root of K all over M. This is how we have the formula for the frequency. Okay. And that is all for today. Thank you very much for watching this video. If this is the first time of visiting this channel, please subscribe to the channel, like and share our videos.